Hi, my name is Matt Deitch, and I'm an assistant professor with the University of Florida, where I work out of UF's West Florida Research and Education Center, located here in Milton at the west end of the state. I teach classes and do research in hydrology and watersheds and water quality issues in the area. And I think it's a fascinating place for a lot of reasons. And so I'll walk through some of these today. The purpose of this video is to describe a little about a research program that we're doing here at the West Florida REC in Milton with my team here in Escambia and Santa Rosa counties. Talk a little about the results that we've been getting, especially related to water quality over the past year. As I mentioned, I think this is a fascinating place to work for a lot of reasons. One of them is just how much precipitation we get in this area. I don't know if you realize this, but this is, you've probably experienced this before and have wondered, we're getting a lot of rain, right? This is one of the wettest places in the United States. We get about 65 inches in an average year of rainfall, and it may occur in a quarter of an inch. It may occur in 10 inches in a day, is not unheard of. We get very large amounts of rainfall in short amounts of time, and we get it all through the year. There's no particularly rainy or dry season. There's certain times of the year when it's a little rainier or a little drier than others, but we can get these big events anytime. And I think it has really interesting implications for how we use the landscape and what we can do here. The other issue that I think is so interesting is that where the area depends a lot on the health of the estuary. And the health of Pensacola and Perdido bays in this area, Choctawhatchee Bay, certainly a little farther east of here, St. Andrew Bay, and the conditions of the estuary and the coastline depend a lot on the quality, the water quality especially of the area. And that water quality is affected not just by the things that go on in the estuary, but also the water that flows into it off of the landscape. And in this area, as more and more people move to this area, to the Gulf Coast of Florida, of the eastern United States here, the southeastern United States, as more people move to this area, it puts some pressures on the landscape and pressures on the ecosystem and on the infrastructure that we have here, especially related to water and water quality. And so I'll talk a little about some of the water quality data we're getting from streams in some urbanized areas here in Northwest Florida, especially in the Pensacola and Perdido Bay areas in the Escambia and Santa Rosa counties. And this is just an aerial image of the Pensacola area. Here's the Gulf Breeze and Milton area here. This is Pensacola Bay that we're looking at here in the middle of the screen. The Pensacola Bay system, Blackwater Bay, East Bay, Escambia Bay, Pensacola Bay, Santa Rosa Sound. This is the Perdido Bay over here on this side. And like I said, it's a great place to work for a lot of reasons. There are a lot of streams that deliver water into this off of the urban and urbanizing area. This is a map showing the U.S. Geological Survey's identified streams in the area. And not just the streams, but also you can see the wetland channels and sloughs and things. This is the Escambia rivers and flows. But the important thing is that there's a lot of surface water channels that deliver water to the estuary. So I want to mention just a little bit about this idea of water quality. I said I think a lot about water quality issues. I have this research project looking at water quality. Water quality, it's a relative term, right? It describes conditions of water compared to some standards or criteria. We say water quality is good, water quality is bad. It reflects what we've measured in the water relative to some particular standards. And I think a lot about how I describe water quality and kind of from my perspective. Of course, I put a lot of it in the context of my own family, my own young family, where things like you can touch the water. It's okay to touch clean water. It's okay to touch it. Just don't drink the water, right? You can touch it, you can play in it, just don't drink it. There are conditions where we might see water where we say don't touch the water. There's some stuff that could be in it. It could be harmful if we touch the water and ingest it or get it on our skin or open sores, things like that. And then we may describe the water quality relative to things we don't want to do, like we don't want to eat the water. We don't want to eat fish that are caught from the water. And why is this? Because there's still a lot of pollution that has an adverse effect on human health that we're concerned about. And those impacts might vary. I think of water quality and pollution, especially. I think of pollution in 5 basic categories. Right, there are things that are living in the water that are harmful to our health, pathogens. They may be particular strains of bacteria like E. coli or like Campylobacter jejuni, which cause intense gastrointestinal distress. Giardia also we put in that category. Maybe some things that are a little more serious like cyanobacteria, Vibrio vulnificus, the flesh-eating bacteria. We've heard a lot about red tide and red algae lately in the past couple of years here in Florida. And more recently, we're concerned about transmission of things like SARS-CoV-2, the virus that causes the COVID illnesses. as also possibly being transmitted by water. So these are pathogens. There are other groups like macroscopic materials. These are things that we can see with our eyes, things like the trash, large and small, and also like sediment, which I'll show in a few minutes. And if you've ever been in an urban stream or seen a retention pond, someplace where water collects, you'll notice a lot of trash washes off the landscape into these water bodies. And there are a lot of groups that do really good work collecting trash. I always like to show, there are a lot of machines that collect trash. I always like to show this. I worked with a colleague in my previous work in California who took the materials that he found in creeks and turned it into a visual garbage museum. So he would travel from school to school through the school year, showing kids what happens and where all that garbage that they, or maybe that their friends might throw in the creeks, where that ends up. And it ends up in creeks, and it's not a great thing to have in creeks, and ultimately if it washes in the ocean, it causes problems. But I think it's really interesting. It's a great visual display of macroscopic materials in streams, and also fine material like sediment, something we see. We look at it visually, though of course it's comprised of very small particles. In this case, clay particles. Clay is very small, but visually we see it at a large scale, and that can cause a lot of problems and adverse effects on water quality as well. Things like nurdles. Nurdles is a hot topic these days. These small plastic particles we might see on the beach. Nurdles are also a type of pollution macroscope. We can see it, we can find it on the beach. There are teams that scour beaches looking for nurdles to identify the spread of this material, these fine plastic materials in the landscape. Inorganic material is another type of pollution we might encounter in waterways. Common things like nitrate, phosphate, sodium, chloride, iron. These are at least the first few are things we might put on the landscape to help facilitate growth, right? Fertilizer we might put on grasses in the landscape, or for fruit trees, or agricultural areas, put in large amounts that can contribute a lot of or inorganic material into streams. Less common things like heavy metals like lead, arsenic, mercury, selenium, radionuclides are also something that are sometimes encountered in surface and groundwater. And these are things that often are a result of industrial processes, or possibly off road landscapes like vehicles and things that wash in the streams. Microfibers and microplastics as well. Organic materials, right? These are some nasty things. Organic compounds that cause big problems. Some of them can be very persistent in the landscape and last for years or even decades. Right. You can see that we can see surface runoff, these types of particles in the landscape. And heat, of course, heat is another type of pollution. Things that cause the aquatic ecosystem to be warmer than it should be. So all these are types of pollutants, and they can have consequences for human health and for aquatic ecosystem structure. So where does that pollution come from in an urban area? I love diagrams like this. I always like to find cool community-made diagrams like this one. What's in our water, right? The way that we manage the landscape and the way that we manage our infrastructure off the landscape has big effects on how much of that pollution gets delivered to waterways, to streams, and ultimately flowing into bays, estuaries, and bayous. And I think this just reinforces that. We can get pollution off of vehicles, we get pollution off yards, off rooftops. All these are potential sources of pollution that maybe in small amounts aren't significant, but cumulatively can have a big effect on what flows downstream. So, as I mentioned, I'm working on this really great project looking at water quality issues in the area, especially in urban streams. We're looking at water quality under low flow conditions. This is a graduate student I'm working with, taking water samples in 8 Mile Creek, not far from here. And this is what 8 Mile Creek looks like under high flow conditions. And you can imagine that the water looks a lot different, right? Here it looks murky. It's carrying a lot more material off the landscape because stuff is washing in off the landscape, off of yards, off of rooftops, off of driveways, off of roads. So we can take grab samples. We can just go out and take a sample of water, run back to the lab and analyze it for things like for water quality characteristics like we can look at nutrient concentrations, we can look at pathogens, we can look at indicators of pathogens. Just interesting things we can look at. It's a wide range of instrumentation that people have. I'll talk in more detail about what we're looking at for this particular project in just a minute. But so we can take grab samples like my colleague Tesfai is doing here, or we could set up automatic stormwater samplers, which can sit in space for a day or two and take samples every hour, every 2 hours, whatever we designate. So in this case, that way the grab samples we take may be able to characterize low flow conditions. Just go out, grab a sample, run back to the lab on a sunny day. The stormwater sampler we can put out if we want to see how things will change over the course of the storm event. So before the storm event, then it rains, water levels go up, it washes all this extra material into the streams. So what's the water like then relative to during the base flow, the low flow conditions before the rain starts? And then how does it change as the water levels drop off over time? So these stormwater samplers allow us to sample without actually being out there. So we're especially interested in a couple water quality characteristics, types of pollutants. We're interested in nutrient levels and fecal bacteria levels, because they are two things that are of special interest. I think in Florida, we're interested in human health. We're interested in how pathogens from fecal inputs, especially from human fecal inputs, might affect our human health, whether they're those types of bacteria I was describing earlier are present in our water. And also nutrients, because nutrients can cause algal blooms, they can cause all kinds of problems in the area, both in estuaries and in streams. And we're looking for, the project's goal is to look for opportunities to improve water quality in local streams through doing projects that would reduce the amounts of fecal bacteria and of nutrients washing into streams. But I'll say, just as a follow-up to that, we're looking at the handful of streams that we're looking at 10 streams total. 5 of them in Santa Rosa County, 5 of them in Escambia County. And I'll show some data and some photos from these streams in a little while. The reason why we're interested in these, ultimately, well, one of the reasons why is that a lot of the estuaries in this area are listed as impaired for fecal bacteria. And I think some of them, I was especially interested in fecal bacteria for putting this image together, but also some are impaired for nitrogen as one of the main nutrients that causes algal growth and other problems in this area. So a lot of the estuaries, the red areas, red shaded areas in this map are showing areas that are listed as impaired for fecal bacteria. So there's more fecal bacteria than there should be for what we want to use these water bodies for. These ecological consequences, there are ecological consequences of nutrient pollution. I mentioned this before, but in particular, these high nutrient loads can lead to algal blooms. Algal blooms can lead to low dissolved oxygen. Low dissolved oxygen leads to widespread fish kills. And this is something that, if you lived in the area 40 or 50 years ago, this was not uncommon, right? There were places in the area that had fish kills. This is a photo taken by the Bream Fishermen Association, showing a fish kill here in the Pensacola Bay area. Our focus is on small streams, especially those small streams that are washing off of urban and kind of urbanizing landscapes. We're fortunate in this area that we don't have, this is not New York City, this is not Los Angeles, we don't have that density of urban development, but there are areas that have fairly high levels of development and impervious surface that does not allow water to percolate down to the ground, but rather wash off very quickly into streams. So there's a considerable amount of impervious area in this region, and so we're especially interested in looking at water quality characteristics in this area. And so the instrumentation that I have in my lab here in Milton allows me to look at nitrate. Nitrate is one form of nitrogen. Think of some chemicals information by mass. Nitrogen comprises 20% of nitrate. So this is just say there are other sources of nitrogen, other forms of nitrogen. Things like you may hear organic nitrogen or Keldol nitrogen if you're ever in chemical discussions, or if you want to impress your friends, you can tell them about what Keldol nitrogen is, the organic forms of nitrogen, things like amides and amines and other aminos, other compounds that have nitrogen. Things like ammonium. Ammonium is another form of nitrogen. And so these are things that other types of instrumentation can analyze. I'm especially interested in nitrate because that's among the most biologically available, that plants can use that very easily. And previous studies that I've done in this area suggested high levels of nitrate in some urban streams. And so I was especially interested in that, and I can analyze for it in my lab. The state has set, the Florida Department of Environmental Protection has set standards for what we think should be the levels of nitrogen in streams before they cross a threshold that they would be listed then as impaired. And so in this area, in the Panhandle West, where we are at the edge of the Panhandle, the total amount of nitrogen, the threshold is 0.6 about 0.7 milligrams per liter. Keep that number in mind. I'll mention it, but just as reference, this is what the state has designated as the threshold for impairment for total nitrogen. That's not just nitrate, but also these organic forms, ammonia that I was talking about before, and so forth. The other thing that we're interested in is that we can look at my lab. I don't know, good slide for this. But we can look at my lab for fecal indicator bacteria for a quantification of E. coli present. And I'll share some of that in some of the images that follow. One more piece of background information. I alluded to this before, but we're interested both in the kind of the low flow conditions, the base flow conditions, but also the stormwater conditions. So this is a graph that we call a hydrograph, showing how stream flow changes over time. We've got stream flow on the y-axis over here, time on our x-axis. So this is over a period of about, let's see, mid-May to early October, what, 3.5 months? Yeah. And when it rains, water level rises very quickly, it recedes relatively quickly. When it rains again, it rises, it goes back down. When it hasn't rained for a long time, water levels kind of stabilize. We call this base flow, the steady low flow conditions we see certain times of year. And we can see this is this past summer, 2021. When it rains a lot, water level rose. When it didn't, it fell. This is in particular. This is from Tom King Creek. This is one of the channels that flow into Tom King Bayou. If you live in that Holly by the Sea area. This was the conditions in during Hurricane Ida this past year, which made landfall in Louisiana and caused a lot of devastation there. Gave us some rain here as well. And also, this is Tropical Storm Nicholas. We can see just how much more water is moving through the streams for Tropical Storm Nicholas, at least in this area. And that's kind of an interesting contrast to something like this is Metron Creek. This is a stream that drains the Metron Estates region near Pea Ridge, a neighborhood in Pea Ridge. This is the same period of time, roughly, I guess a little shorter time, but this is a much smaller stream. It's much flashier. When it rains, that is to say, when it rains, all that water runs off the landscape very quickly, and then it drops down to almost no flow very, very quickly. So just kind of, instead of this gradual rise or recession, in these small streams, everything's washing in really fast. Anyway, so we're interested in characterizing nutrient and fecal bacteria levels. It's really what I'm going to do in the rest of this talk. Okay, so just kind of during base flow conditions, we looked at nitrate-N nitrogen concentrations in 5 Northwest Florida watersheds and kind of the 10 and 11 Mile Creek system, Bayou Tahar. I'll show some images from some data from Carpenter Creek as well in a few slides. Tributary to Bayou Grande, which I'll talk about in a second. The Tom King Bayou drainage network, and then the kind of the Sugar Creek Thompson Bayou area. I thought this was interesting. So this is base flow conditions in July 2021, where I think this is the time when it hadn't rained a whole lot in July. So if we were sampling kind of late July, let's see, late July is a little drier than say earlier in the month. And in general, the concentrations of nitrogen were pretty low. Of nitrate-N were pretty low. They exceeded thresholds at a few places. One in Bayou Tahar. You know Bayou Tahar. If you're familiar with local water quality issues, Bayou Tahar tends to have a little high nitrogen. It's just the nature of that, some of the issues going on that stream. And then this is in the Sugar Creek system as well, which I'll show in a map in a few minutes. But in general, the nitrate-N levels are very low in these streams. This is a couple months later in September, the same stream. We had a few more sites at this point. We have a few more sites now. We've got some in 8 Mile Creek, a couple in I think this is one of the ones in Carpenter Creek now. In general, the levels, especially like Tom King Bayou, very low, Bayou Grande, pretty low, 10 Mile, 8 Mile, 11 Mile Creeks, pretty low as well. Sugar Creek, mostly low, a few that are higher, almost at the threshold of what's considered for impairment. So I think that's really interesting. Kind of to show related to this then are amounts of E. coli, our E. coli abundance through the drainage network here. So now we're looking at, I've got 2 images I'm showing here. I'm showing, this is the 10 Mile Creek and 11 Mile Creek drainage network. And then this is 8 Mile Creek. And right here, this is all flowing toward Perdido Bay. And I'm showing then, what I'm showing on the map is both the drainage network and the abundance of E. coli present in the channel. This is using a technique called IDEX. They're cold alert tests. So we took samples, water samples, rushed them back to the lab, put them on ice, rushed them back to the lab, and within a few hours began the analysis to quantify the the E. coli abundance in streams. And so the threshold for impairment of E. coli in streams is considered around 400. 400 is the MPN, the most probable number. So if anything that's red is considered pretty high for impairment. And in the 10 Mile Creek drainage network, 11 Mile Creek, we're pretty low. 8 Mile Creek, not quite to 400, not quite to exceeding that, but in the samples we took, they were low, kind of in this upper area. This is flowing downstream then, when they're lower downstream. Carbon agreement, Bayou Tahar, again, not surprising if you know, the county has some programs going on in the Escambia Creek and Bayou Tahar, the Carbon Creek Bayou Tahar area, to try to figure out how they can reduce E. coli in the stream. And so yeah, this comes up, and we see that in here as E. coli having issues. This is in June 2021. Same streams, now this is July 2021. We've got still pretty low values through the 11 Mile Creek and 10 Mile Creek area, 8 Mile Creek as well. Bayou Tahar, pretty high up at the top, lower, farther down. In September, things are starting to get a little high in 8 Mile Creeks, still pretty low in 10 Mile Creek and 11 Mile Creek, still pretty high in Carbon Creek, I should say in Bayou Tahar. And then in November, we took one more set of samples in November, because it's still pretty high at one of the sites in 8 Mile Creek, but then lower farther down. What does this mean, right? What does this mean? There's a lot of variation. I think that's what's one thing. There's a lot of variation through a drainage network, although sites tend to be consistent. Like this site here, this one that's red. Let's see if I can point to it if I say, yeah, it's red here in the November, tended to be the highest one through the course of the project. I guess not necessarily there, but this is 10 Mile Creek, right? 10 Mile Creek in September. It's pretty high in November as well. A few sites kind of the upper part of 8 Mile Creek. But in general, the E. coli level, so this is a measure of how much fecal bacteria is in streams, tended to be pretty low. That's actually pretty good, right? I think that's good news that in a lot of the area, based on the samples we took, the times we took them, the E. coli levels were low. Carbon agreement, so by November, Bayou Tahar had lower concentrations, certainly before that, right? Lower amounts of E. coli. Before that, they were pretty high. So here's November. I had mentioned before this, we had some streams in a tributary to Bayou Grande. There's a lot of interest in finding ways to improve water quality and reduce flooding in Warrington, in the Warrington community. One of the most difficult things to find a place to work in this area, as we were thinking about looking for streams in this area, is that there aren't many surface streams in Warrington. I think like much of the older urban area of Escambia County, the streams were buried a long time ago. The stream channels were put into culverts and other types of pipes, and so that the water washed off the landscape very quickly and went into these culverts, ultimately into very, very quickly off the landscape. And that causes a lot of problems because as the area continues to develop, as we get bigger parking lots, more rooftops, more driveways, more houses, as that area begins to develop, continues to develop, the amount of surface runoff during these high flow, these high rainfall events increases. The size of the pipes can't increase without a big expense of improving infrastructure, right? So the pipes stay the same size, but if we have more and more water, then that has to fit this small into the same size pipe, and then it can cause surface flooding because all that water can't go into the pipes. So what we're interested in especially the water quality in this, there's a stream that flows into Bayou Grande. This is Jones Creek, Jones Swamp area. If you're familiar with the area, Jones Creek, Jones Swamp. This is a small unnamed stream. I didn't see a name for it here in Warrington. I mean, it crosses. One of our sites calls it. One of the sites crosses Mills Avenue, so we call it Mills Creek, just kind of out of convenience. But in Mills Creek, this is in June. E. coli levels were kind of high, but not too high, not above the threshold. Oh yeah, so there's a lot of flooding in this area. This is just I like this map because it shows low elevation areas in kind of the southern Escambia County. We can see. So this is just showing areas. This is feet. Above sea level here, so this is areas that are below sea level are in blue, and this dark blue, like this is by Chico, right? And then above sea level is up to 10 feet. And then the area that's not colored, shaded by this rainbow of colors, is above 10 feet. But this is just showing that in the South Escambia County area, a lot of this area here in Warrington is below 10 feet in elevation, and maybe subject to flooding from things like storm surge a little more easily than farther up. Downtown, this is downtown Pensacola, which has flooding issues as well. So yeah, so this is July. This is a month later. We added a site a little farther out. Still it's still below thresholds that are considered impaired. Then by September, this site, yeah, we're starting to get above thresholds for impairment. I think this is above 1,000 is a lot more than 400, right? If the impairment is 400, you have some sites that are above 1,000 or even 2,000. The other streams we're looking at, Tom King Bayou and Sugar Creek. Tom King Bayou, this is the Holly by the Sea area right here, right? Tom King Bayou is this. There's a drainage network that flows into Tom King Bayou off the landscape. And then over here, Sugar Creek drains north into, this is Thompson Bayou, right? This is West Florida Hospital in this area, 9 Mile Road, if you're familiar with the region. This is the Escambia River up here. So we had several sites here in Sugar Creek, several in Tom King, the Tom King Bayou Drainage Network. We had another one just here at Navarre Park that always had very low E. coli levels. There's not a whole lot of watershed there. Or at least, especially not a lot of people living in the area. Yeah, so this is in June. A few sites that are above the threshold for E. coli abundance, above what's considered a threshold for impaired. This is a Sugar Creek. Not any sites, I guess, here in June. By July, this starts to change. Right? So by July, maybe it's that there was a little more rainfall, or maybe actually, I guess it was the things were a little drier in July. Maybe I think it was the rainfall that we started to get more rain, precipitation. So this is speculation, right? We start to get a little more precipitation. Maybe that starts to connect things and wash water through the Tom King Bayou drainage network effectively, where we start to see more bacteria in Sugar Creek. This is July. By September, the Sugar Creek area, a lot of the streams have very high levels of fecal bacteria, where here in Tom King Bayou drainage network, they're pretty low. And then in November, that starts to switch back again. So we start to have low bacteria counts here in Sugar Creek, higher bacteria counts over in Tom King. So it's interesting. Again, what does this mean? I think it says that there are some streams where I would be uncomfortable with my kids playing in, I guess. But there are some times when it seems to be okay. It's hard to make a judgment for like the health of your family knowing this. I'm not quite sure where we'll take this exactly and how we'll work with the county. Maybe more with the counties or with the Pensacola Bay Estuary Program. Maybe more frequent sampling, maybe some kind of signage saying what the bacteria levels are like. So, and then we're interested in storm flow because these are the flow conditions when most of the stuff gets moved, right? So there's a lot of water washing off the landscape, and it can carry all the material that washes off the landscape along with that water. So it can carry a lot of stuff. And it's usually considered that nutrients like nitrate, phosphate, a lot of that washes off the landscape. A lot of that is in highest amounts during storm events. So we were interested in seeing if that's the case in this area. Some of our previous work in Carpenter Creek in Escambia County suggested that the concentrations go down during these high flow events, but the total amount of stuff, even though the concentration goes down, if you think if you have a teaspoon of sugar and you put it in a cup of coffee, right? That's kind of your baseline condition. There's a lot of sugar in that coffee, right? If you put it in a big pot of coffee, then it's more diluted. There's less. The concentration is lower. If you put 2 scoops in that pot of coffee, the concentration is still lower than what's in the cup of coffee, but there's more of it. There's more sugar in that pot. I hope that makes sense. That's this idea of the total amount of stuff that gets carried it tends to be higher in storm events because there's a lot more water washing. So even if the concentration is lower, the total amount is a lot higher. Yeah, and that ultimately can affect the bays and bayous. Even though this tends to occur over a shorter period of time, that can have a higher effect on bays, estuaries, bayous because that could sit in those estuaries for a prolonged period. So yeah, and as I mentioned before, a lot of that storm flow where it's carrying material off the landscape. Here's me standing in a big parking lot. All that parking lot that washes off, materials wash off the parking lot into this very efficient, effective means of carrying water off the landscape. Right? We put these stormwater pipes all over to carry these culverts all over to carry that water off the landscape. That can ultimately go into stream channels. This is showing in a creek in Escambia County, showing those disconnected pipes and how it's going right into the stream. So I have some data from. I'll try not to spend too much time because it's going to be long. But I have some great data from several streams that I'll show during these storm events. Like, for example, this is the Metron Creek watershed. I talked about Metron, the Metron Estates neighborhood in Ridge. There's a creek that drains north this way into Pond Creek. And it has some issues with fine sediment for sure. This is a house that that Santa Rosa County has bought to, I think the plan is to expand the retention pond that's here to try to reduce the amount of whatever washes off the landscape going into Pond Creek. Again, this is just getting a sense for it. Yes, there's a lot of stuff that washes off the landscape and goes into the creeks. So this is the Metron Creek, the hydrograph over the course of this summer, the pattern of stream flow over time. We look at a couple places. We put out stormwater auto samplers, and in general, during base flow times, the concentrations of nitrate are pretty low. Of nitrate-N are pretty low. This is our threshold of impairment. Low levels of nitrogen for nitrate, below levels of impairment. The E. coli was high. I didn't talk about E. coli in Metron Creek before because we only have one site in the stream in the drainage network. But the E. coli levels tend to be pretty high in the stream. The threshold for impairment is 400. These values. We took a sample in February, samples in February and May as well, and they were low. But here in the summertime, they were considerably higher. We took a lot of samples during Hurricane Ida, so that was really the focus of our stormwater sampling this year. Hurricane Ida and also Tropical Storm Nicholas, but I'll focus especially on Ida for the next few minutes, showing some of these images. So this is showing if our threshold for impairment is this 0.7. This is nitrate-N on our y-axis. 0.7 is our threshold for what's listed as impairment. Our measurements are all pretty low. We were taking samples both from what was in the creek and also what was washing into the creek from the stream. And in all cases, the nitrate levels were below the level of the threshold considered for impairment, but not there was some nitrogen in the streams. Tom King Creek, there was a particular site in the Tom King drainage network that we were interested in. This is at, I think, Valley Road. It's funny, I just drive in now through just memory now. I'm not quite sure. I'm pretty sure I said Valley. If you live in the area, you may know this set of culverts. Right here. So it's located right. Actually, maybe I think it's located right here at our site. And so this is over the course of Hurricane Ida. I mentioned Hurricane Ida brought a lot of rain in parts of the southeast. Not as much here, but still, I think there were some areas that reported up to 10 or 15 inches of rain. So we did get some rain, some intense rain in this area over a period of about 3 or 4 days. But the nitrate levels, the nitrate-N, here's our threshold. They're all these orange dots all here are pretty low. We put out a stormwater sampler during Tropical Storm Nicholas, and again, all the water nitrate-N and water samples we took during this high flow event were all pretty low. In Sugar Creek, I'll show, this is just showing kind of comparing the hydrology. I'll skip past this for now, but we took some samples. I mentioned this creek in Navarre Park as well, if you're familiar with the area. There's a creek that flows into Santa Rosa Sound in Navarre, not far from the bridge, the Navarre Beach Causeway. There's a small stream that flows in. This photo I took shortly after the first wave of rain during Hurricane Ida. You can see the grass is pushed down here, so there's a lot of water moving through this small channel. A lot more than that. We had to take out a water sensor because the county was doing it, and FDOT were doing some road maintenance, and they recommended we take our sensor out, I think, a few weeks before this storm came through. So we don't have water level or stream flow data for this site, but we can see the concentrations of nitrate-N. We did take samples through the storm. They're all much lower than the 0.7 milligrams per liter of threshold. We were interested in some small creeks like this one in Florida Town as well. If you're familiar with Florida Town Park is just across this road. It'd be just over here across the street. This is we were taking water samples from a confluence of two of these concrete channels. One here, and there's another one that runs along the street. Kind of this is northward here. There's another small channel behind this guy. Check his email. And so at the confluence of all these concrete channels come together, we're taking water samples there. And we do have water level data from this. It's water level when it rains. We can see when it rained, water level went up a lot. When it stopped raining, it started to recede. And our first water sample we took, so this is dry almost all the time. This is dry, 95% of the time. When it rains, it's wet. Otherwise, it's a dry concrete basin. And I think that we took this first sample right after it started to rain. when there was just a little bit of water in that had very high nitrate-N level, and then it dropped down through the course of the storm. We also, during Hurricane Ida, during Tropical Storm Nicholas, we put out some auto samplers, so I have that here. Yeah, so here's during the storm event, the nitrate-N levels were pretty low through this storm event. That was Tropical Storm Nicholas during this. So here's our threshold for impairment at 0.7. You can see just how low those nitrogen levels are. In Sugar Creek, this is Sugar Creek. I mentioned the high E. coli in the summertime in this channel. In Sugar Creek, as far as the nitrate-N, the amount of nitrogen, this is our hydrograph, our blue line showing stream flow patterns. Our nitrogen levels are all pretty low in the samples we took. And in this case, we weren't taking in this case, we weren't setting up an automatic stormwater sample. We were actually going out every day, taking 2 samples, and running those back to the lab to see how they compare, to see what the concentrations were. So yeah, again, all pretty much lower, much lower than the threshold for impairment. Tenbaugh Creek is interesting for a lot of reasons. It's one of the few places you can see whitewater in this area. This is actually a restoration or bank stabilization project at Pine Forest Road, where Tenbaugh Creek goes under Pine Forest Road. Yeah, it's a pretty exciting place. I haven't canoed this yet or kayaked this yet, but maybe next time. Yeah, the nitrate-N levels were very low here as well. So the stream flow rose very quickly when it rained and receded. This is over a period of 5 days, with 1, 2, 3, 4, 5, 6 days. The nitrate-N levels were pretty low through here as well. 8 Mile Creek, this is not far from Tenbaugh Creek. 8 Mile Creek, our water level sensor was stolen at this site. If you happen to have the water level sensor, you can mail it back to me at the West Florida REC. But so I'm showing that this is it's right next to 8 Mile Creek, so it probably has a similar pattern of hydrology. And this is showing the nitrate-N levels for the samples we took at 8 Mile Creek. So this is 8 Mile Creek. So these orange dots are from 8 Mile Creek, but the blue line is 10 Mile Creek. It's just a little confusing explanation there. But yeah, the nitrate-N levels were all very low during this time as well. Yeah, so it was surprising to me to see how low the nitrate-N levels were. The nitrate levels were in these streams, especially compared to how high I'd seen them in Carpenter Creek just a few years before, where the nitrogen levels were 1 to 2 milligrams per liter of nitrogen, so far in exceedance of what's considered as impaired. Yeah, and the nutrient, at least in terms of nitrate-N, were consistently below thresholds of impairment. I do expect to get an instrument to look at organic nitrogen later this year, and so I'll start to look at what kind of organic nitrogen concentrations there might be, and how that might be. That's a contributing factor to the total nitrogen in the system as well. And the bacteria levels vary by stream and by season. There were some streams that had very high levels of bacteria at certain times, some that were very low at other times, some that had kind of consistently high levels during the summertime. That's interesting to think about and think about what kind of processes or practices we might be able to implement at a watershed scale to reduce those levels of bacteria. That's something that I will aim to work with homeowners and with the estuary, with non-regulatory, consensus-based programs like the Pensacola Bay Estuary Program in the future as well. So that summarizes what I wanted to talk about in this video. That's, I think, a pretty good summary of the water quality, especially related to fecal bacteria and nutrient pollution in the Pensacola Bay, and streams that flow into the Pensacola and Perdido Bay systems. My name is Matt. My kids call me Dr. Deitch. My name is Matt Deitch. I work here at the West Florida Research and Education Center. I'm in the Soil and Water Sciences Department. You can email me, or you can also check out, I've got a great video on green infrastructure in Northwest Florida, some innovative projects that people are doing in this area to promote green infrastructure, kind of mimicking natural processes, nature-based solutions in this area. And so with that, I have some samplers I have to go check, and I'll catch up with you again soon.